Okay, section 2.1 is where we are going to analyze figures using the definitions of angles and parts of an angle. So we're going to be able to name certain rays, certain opposite rays, certain angles, and then also vocabulary like interior and exterior. We will also look at interpreting diagrams to make sure that we have some specific vocabulary words in there. So this first example is just practicing using all of these vocabulary words. So before I start with that example, let's go through some of these. So a ray is a part of a line consisting of a point called the endpoint, and it's going to extend in one direction. So for example, I have the ray AB. So that means my endpoint is at A and my arrow is going towards B. So when you write out a ray, it's important for the symbol that you have your endpoint above the correct letter because you want to make sure it coincides with which one is the endpoint. So if I was going ray AC, I would start at A and then it would extend through C. If I was going CA, that would be different because my endpoint would be starting at C and going in the opposite direction. Okay, opposite rays are two collinear rays with a common endpoint. So for example, AD and AB are opposite rays. So if I'm at A and I go towards D, and I'm at A and I go towards B, those are opposite rays. So they share the same endpoint and they go in opposite directions. Always opposite rays form a straight angle. So remember, a straight angle equals 180 degrees. An angle is a pair of rays that have a common endpoint. This is an example of an angle. There are several ways you can name an angle. You can use the vertex. So angle A is the vertex. You can use 3 points as long as the vertex goes in the middle. So angle DAB or DAC, and then you can also go in the other direction, CAD and BAD. So it's important that the vertex goes in the middle. You can also name an angle using a number. So like down here, they say angle 2, and I could use this as my angle. The very last box, it says the rays are called sides of the angle, and the common endpoint is the vertex. So you may have already heard me say vertex. So point A is the vertex of this angle, and then this angle has sides AD and AB. So the rays are the sides, and then that point is your vertex. Couple other things, just making sure you know vocabulary. These points lie on the angle because they're right on top of there. These points are on the inside of the angle, so anybody on the inside. And then these points would be on the outside of the angle. Okay, so knowing what's on the in and what's on the out. All right, let's jump down there to example 1, see if we can make some sense of this. So it says, use the figure to identify the angles or parts of an angle that satisfy each condition. So I have this big picture, and then my first question says, name all the angles that have D as a vertex. So D is squished right here. So here's this point. So the first one that I wrote down was EDF. So this angle right there. So notice that I put D in the middle. Another angle is EDG. So this one right here. And then I just kept going around. FDC, so this angle over here. GDC, which is this guy on the right. Now there's a couple special ones inside of there. So you can also use this small one, GDH. You can also use this small one, HDC. And then last, you can put those together and make this guy right here, so FDH. I'm not so concerned about you being able to name everyone in a picture, just more importantly, making sure you can see them all because those have some special effects later. All right, letter B, name the sides of angle 2. So locate angle 2. The sides of that angle would be ray, BD, and ray, be A. So notice how I wrote it. I made sure my symbol, the endpoint, was above the B because B is my common endpoint between those two. Letter C, name a point in the interior of FDE. So I locate that angle. Here is FDE. The interior would be inside of that guy. So a point that's inside of there would be A. Letter D, name a point or points in the exterior of FDE. So we just got doing the inside. So now I'm going to change to the outside of that same angle. So the outside would be anybody on the out of that. So in this case, you could have picked C, H, or G. You just can't pick any of these points along that angle because they lay on top of there. All right, so what I want you to do is flip your book over, and I want you to come over to this very first check question. So this guy right here, and see if you can figure out all of the angles for these two rays. Okay, so for this picture, they are wanting you to do ray DB and ray DC. So one way I can name that angle is just angle 2. Then I can also name it CDB and also BDC. These other three do not work. So angle 3 is not in the red that I highlighted. ADB is not in the red that I highlighted. And EDC is not in the red that I highlighted. All right. Back on that first page, I just want to point out some vocabulary down there at the bottom. So down here in your picture, we already know what congruent means. Congruent means that you have the same measurement, okay? They are equal. So in a picture, they will put these little arcs here to show that those two angles are equal. When they're writing it out, they will still use that congruency symbol. Another vocabulary word that's going to pop up a lot is angle bisector. Bisector means you're cutting it into two congruent parts. So that goes for a segment or an angle. In this case, if they're bisecting an angle, these two angles have to be equal. All right. So jumping over here to example number 2, it gives me a whole bunch of stuff. First, it tells me that BA and BC are opposite rays. It also tells me that BD bisects this angle. So if it bisects, that means that these two angles have to be equal to each other because it cuts it into two congruent angles. I labeled ABD. I also labeled DBE. If these are two equal, then I'm just going to set my equation up where they are equal to each other. So I solved it where I minused everything and divided, and I got x to be 11.5. Then I go back and I read the question again. It wants me to find this angle measurement. So I'm going to take that 11.5 and I'm going to plug it back into this expression. And that's what I did here. So I found that my angle was equal to 60. I'm going to have you pause the video and try this check question down below. So after you read through there, you should have found that these two guys were equal to each other. And so you're going to set those two equal and solve for x. They want you to find angle JKN. So I plugged that 12 back into that expression and I found my angle was 83. All right, so that concludes day 1. So if you're needing day 2 of the notes, all right, so day 2 is where we start talking about some more specific angle pairs. And these are pretty important because they keep coming back over and over again. So adjacent angles are two angles that lie in the same plane, have a common vertex, have a common side, but no common interior points. So what that means is adjacent is they are right next to each other, okay? They just can't be laying on top of each other because then they're sharing those inside points. So adjacent means right next to each other where they share the side and they share that point. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So for example, linear pair has to be adjacent, so they're next to each other, and they're going to add up to 180 degrees. So they'll always form a straight line. So over here, you can see that these two are a linear pair because they're adjacent and they add up to 180. This would not be an adjacent pair because, a linear pair because look how it's not forming that straight line. That means it would not add to 180. And then the last one over here for vertical angles, two non-adjacent angles formed by two intersecting lines. So I always refer to this as the X, so the vertical angles are the X shape. But pay attention to which ones are the actual pairs of vertical angles. 1 and 3 are vertical, so left and right, and 2 and 4, up and down. One thing we always know about vertical angles is they're going to be equal, okay? So over here in this picture, this would not be vertical angles because we don't have straight lines that make that X shape. So this line would need to come through here in order for it to make vertical angles. All right, let's see if we can work through this last example together. So example 3, the office lamp is made using two intersecting metal bars. How many pairs of adjacent angles do you see? List two pairs. So adjacent angles mean they need to be next to each other. So there's lots of pairs here. So I picked ABD and DBC. So those two right here. And then I also named DBC and CBE. It wanted to know how many pairs there would end up being 4 pairs because I can go all the way around naming those. Identify two pairs of vertical angles. So it would be these two angles and these two angles. Now be careful how you name them. You can't just say B because I won't know which angle you're saying. So ABD is the left, EBC is the right. So the left and right, and then top and bottom, ABE, DBC. How many linear pairs do you see? Well, there would also be 4. So 1, 2, 3, 4, and then list them all. So ABD, DBC, there's 1. DBC, CBE, there's 2. Then these 2, and then these 2. Find the measure of EBC. In the previous example, I showed you that vertical angles are always congruent. So since these two are vertical, this guy would be 138. And one side note is if I know these, I'm going to know all the way around if they're vertical angles because these are going to be a linear pair. So that means these have to add to 180. So if I do 180 minus 138, I'm going to know that this guy has to be 52, which then also makes this guy 52 because all the way around there, they should be adding to 180. All right, pause the video and try the check question. Oh, I guess I was supposed to do, I'm off on my math. Sorry, 42, not 52. All right. Okay, so in the check question, you were supposed to figure out which statements were true. So DEF would have been 92. That's true. DEG was equal to 92. That's false because in the picture it says 88. FEH would have been 88 because these are vertical angles, so that's true. DEH would have been a straight line. That would have been equal to 180, so that's not true. And then GEH is equal to 92, so that's not true. So just A and C. So this section is really focused on a bunch of vocabulary words that you're going to want to make sure you put down on your frame.